Welcome to Japan Railway Journal. I'm Mickey Clark. This is a depot for the Tokaido Shinkansen in Tokyo. This facility can accommodate over 60 Shinkansen train sets where inspections and maintenance are carried out day and night. This yellow Shinkansen is the inspection Shinkansen, which checks the condition of the tracks and overhead wires as it runs and detects any abnormalities. It's been 60 years since the opening of the Tokaido Shinkansen. Today, let's take a look at the maintenance work of its tracks and vehicles.
JR Central's Tokaido Shinkansen, which operates frequently, runs at a maximum speed of 285 kilometers per hour. Because of such heavy use, a special vehicle is used to inspect the condition of the tracks and overhead wires. This bright yellow Shinkansen is nicknamed Dr. Yellow. Dr. Yellow runs about once every 10 days. While in operation, Dr. Yellow uses sensors and other equipment to measure rail distortions and wear on the overhead wires. It also collects data on operations shaking and shocks for track maintenance work and other operations. The train also stops at stations to examine the condition of the tracks and overhead wires as it accelerates and decelerates. Dr. Yellow consists of 7 cars, each equipped with purpose-built inspection devices. Car 1 inspects the flow of communication signals that run along the rails. These signals transmit various information about the train, such as its running status, to the General Command Center. On top of cars 2 and 6, laser devices measure the overhead wires. Laser beams are directed at the overhead wires. From the way they bounce back, the degree of abrasion caused by contact with the pantograph can be calculated to the nearest millimeter. Overhead wires like this one can wear out in as little as 1 year. Worn overhead wires interfere with the power supply to the vehicle. Cars 3 and 5 have what are called observation domes. These domes are equipped with cameras to inspect the pantographs. They also have seats, so inspectors can check the pantographs directly. Car 4 checks the condition of the tracks. Under the floor, a laser reference device measures to the nearest millimeter rail distortion in relation to the car body, vertically and horizontally. If any device on Dr. Yellow detects abnormalities with the tracks or overhead wires, it automatically transmits that information to the General Command Center. From there, the information is passed to the team in charge of track maintenance. Once a report is received, the track maintenance team carries out repairs as soon as possible. The repair work happens overnight, in the few hours between last train and first train the next morning. Here, the overhead contact wires are being replaced. The overhead maintenance vehicle leaves the used wires in place while the new wires are installed on the line. The used wires are then removed and new wires are secured manually. The hangers are 5 meters apart, So replacing the wires is a gradual process. After installing the new wires, this vehicle moves in the opposite direction, winding the used wires onto a drum as it goes. One of the reasons a track might sink or slant is worn ballast. The shaking caused by passing trains causes the ballast to become rounded. This is why the ballast needs to be replaced. First, a trench is dug beside the rail. A ballast exchanger is then brought in. The undercutter bar at the front is lowered. It then digs underneath the track and scrapes out the old ballast. A conveyor belt then moves the new ballast forward so it can be put in place. Next, a ballast tamper is moved into position. These claw-like devices tamp down into the newly laid ballast to help it settle. At the same time, the track is raised and lowered to make sure it's aligned correctly. Here, a rail is being replaced. First, the section being replaced is cut. The bolts are then loosened, and the old rail is removed from the concrete sleepers. Next, a rail replacer is used to exchange the rails. Although the rails are made of steel, they're long and thin and very flexible, as you can see here. When a rail is replaced, the new rail is positioned on the outer side and gradually pushed inwards. At the same time, the old rail is pushed outward, and the machine moves forward. Next, the new rail is welded to the existing rail. Using a method called gas pressure welding, pressurized atoms cause the new and old rails to bond, forging them together. The slightest bump at the point of connection will have an effect on the train as it passes. So they carefully shave down the joint in 0.1 millimeter increments until it is smooth. The tolerance is strict, just 0.1 millimeter for the surface and 0.3 millimeters for the size. Finally, a special measure is used to check that the width of the rails is correct. If there is any deviation, a crowbar is used to gradually adjust the position. Midnight line maintenance work continues throughout the year. Dr. Yellow has been a part of this maintenance work since its introduction over 20 years ago. However, it has been announced that it will soon be retired due to its age. JR Central's Dr. Yellow will be discontinued in January 2025, and JR West's Dr. Yellow will be discontinued soon after in 2027. There are no plans to replace the inspection cars. Instead, Dr. Yellow's inspection and measurement duties will be handled by the N700S, a commercial vehicle. The N700S, the newest model Shinkansen, debuted in 2020. Special equipment will be installed on the cars to collect data while in commercial operation carrying passengers. Currently, 6 N700S train sets equipped with this equipment are undergoing running tests. First, a device was developed to inspect the overhead wires on the roof. Infrared beams are directed at the overhead wires to check their condition. The suspension fittings are photographed and checked at the same time. Infrared rays are less susceptible to interference from sunlight, making more accurate inspections possible.
高速走行中に架線の位置関係を3次元的に計測して量比を自動判定することや、電車線金具の画像を取得し AI を用いて変形や破損などの異常を自動検出できるようになります。
With the introduction of the new inspection equipment, data equivalent to or better than that of Dr. Yellow can now be obtained, increasing the reliability of the inspection results. A device was also developed to measure the condition of the railway under the floor. Lasers check the shape of the rails, looking for vertical and horizontal misalignment. This image of the track was taken by the inspection device. This high-precision image is used to detect rail misalignment and cracks. On the left is the point cloud data. Like a topographical map, contrasting colors show the height and depth of the track. It is used to detect the displacement of the bolts holding the rails in place, which indicates whether they're loose or not.
現在、社員が全線を徒歩で移動しながら目視確認だったり、計測器具を用いて行っている起動材料の点検回数を削減するために開発しました。
The installation of inspection equipment in commercial vehicles is expected to provide frequent, highly accurate inspection data, enhancing safety to a greater degree than ever before.
Well, since Dr. Yellow had supported the safety of the Shinkansen and was a popular train, its retirement will surely be missed.
I think so too. But the problem of the Dr. Yellow is that it can reach the top speed of 270 kilometers per hour, but all other trains for revenue service on the Tokaido Shinkansen can none reach 285, and that difference is making the pathing of Dr. Yellow among all other trains becoming more difficult. Now, then came the decision to withdraw Dr. Yellow and replace that with the service train sets with all those measurement devices on board.
And nighttime maintenance work is also essential for ensuring safe operation. And I was surprised to see the precision of the track replacement, especially the repairing of the surface of the rail with an accuracy of 0.1 millimeter.
I see. Well, Tokaido Shinkansen is operating at a very high speed, and together with that, the frequency which is really comparable to the morning and evening peak hour operation on the commuting trains. So I think that kind of operation is possible only with the existence of all these maintenance workers and their expertise.
Yes. Well, next, let's take a look at the maintenance of the Shinkansen vehicles.
The Tokaido Shinkansen operates more than 360 trains a day. This includes the fastest Nozomi trains, the Hikari trains, and the Kodama trains that stop at every station, all with different travel times. At times, as many as 17 trains per hour depart from Tokyo Station. Despite such a busy timetable, the average delay per train per year is about 1 minute, including delays caused by natural disasters. Between each precision Shinkansen operation, staff carry out the important duty of maintaining and cleaning the train carriages. At Tokyo Station, it takes 36 people to work on a 16-car Shinkansen. They hurry to rotate seats, change covers, and collect trash, all within 10 minutes. One of the most burdensome interior maintenance tasks is checking for wet seats. Very wet seats have to be replaced. In the past, each seat was checked by a staff member using a special broom that could detect wetness. Now, new equipment makes the task simpler and physically easier on the staff and their backs. At the end of this extendable pole is a thermal imaging camera connected to a smartphone. The camera uses AI to detect wet spots based on temperature differences. This information is displayed on the connected smartphone. By completing onboard inspections within 10 minutes for all turnaround trains, the Shinkansen is able to remain on schedule. The longest of the Tokaido Shinkansen trains travel more than 3,000 kilometers per day. The maintenance required to keep them running safely is determined in stages, depending on the distance traveled and the number of days in operation. A pre-service inspection takes place every 2 days. 20 workers are responsible for over 60 trains a day. Each train, which is 16 cars long and 400 meters in length, spends around 50 minutes being inspected visually and with specialized instruments. Sound inspections are also performed using hammers to check for loose bolts. If necessary, the workers replace parts and make adjustments. After the pre-service inspection, the car body is washed. This is also done once every 2 days. In addition to the pre-service inspections, regular long-term inspections are scheduled while the train is in service. Regular inspection occurs after 45 days of service or 60,000 kilometers. The running gear, motors, electrical equipment, and brakes are all inspected. At 20 months, or 800,000 kilometers, a bogie inspection is performed. Maintaining the bogies is crucial when it comes to safety. Motors, brakes, and other components are removed from the bogie frame and inspected in detail. In particular, the inside of the wheel axle is carefully inspected using a camera. Lastly, the wheels are polished to ensure that they're even and smooth. After 40 months or 1.6 million kilometers, a general overhaul is performed. The overhaul takes approximately 2 weeks and involves disassembly and a detailed overhaul of the entire vehicle, from the body to all of the vehicle's equipment. This innovative new technology is being promoted as a way to improve the vehicle maintenance process. Pre-service inspections are conducted manually every 2 days, which takes a lot of work. Now, the company is testing a system that automatically inspects the exterior of each vehicle. The system relies on cameras and sensors placed at the entrance of the workshop. When a vehicle enters the workshop, every inch of the exterior is automatically photographed from all angles. A dedicated program then analyzes the images to detect body damage, loose bolts, and other abnormalities. With the introduction of this system, the manpower required to conduct inspections can be greatly reduced. As a result, inspections can be performed more frequently than before, leading to improved safety.
Well, I could see how the Tokaido Shinkansen have been supported by steady efforts over the past 60 years.
Yes, indeed. There's a shining side, in my opinion, on the Tokaido Shinkansen, which are vehicles and their technologies. But at the same time, I think that there's another side which is more difficult to see, which is the group of maintenance workers doing maintenance on tracks, contact wires, vehicles, and so on and so forth, and their day-to-day hard work and their expertise. I think without them, the Tokaido Shinkansen could not have continued the safe and reliable operation for the past 60 years.
I think so too. Well, however, what caught my attention this year was a series of accidents involving the Shinkansen.
I am concerned as well.
And in January, the Tohoku, Hokuriku, and Joetsu Shinkansen lines experienced power outage, and some sections were suspended throughout the day.
The cause was the component which was called the tension balancer, which adjusts the tension of the overhead wires. And that component broke, resulting in the wire sagging and hit the running Shinkansen train. And that component had not been replaced for 38 years and had become old and worn out.
In July, maintenance vehicles of the Tokaido Shinkansen collided with each other, derailing both cars. As a result, operation was suspended throughout the day on some sections of the line.
JR Central has indicated that it was caused by an incorrect inspection method of the maintenance vehicles, and that the company was unaware that the braking effort of that maintenance vehicle was insufficient.
In September, the Hayabusa and Komachi services bound for Tokyo traveling at a speed of 315 kilometers per hour on the Tohoku Shinkansen as one train suddenly became uncoupled, triggering the emergency stop. Although there were no passenger injuries, operation of all Shinkansen trains were suspended for 5 hours.
According to the investigation by JR East, a number of metal fragments ranging from a few millimeters to 2 centimeters in size were found around the switch used to activate the emergency decoupling mechanism on the Komachi side of the driving cab. And these pieces of metal are believed to have come into contact with the terminals of that switch, triggering that emergency decoupling mechanism. And these pieces of metal fragments are believed to have been left over since the vehicle has been manufactured at the manufacturer more than 10 years ago.
So there were several accidents on various Shinkansen lines. What were the problems?
It's actually difficult to say because there is no common cause for it. But I can certainly say that in many cases the human errors are involved in that, so we can address that. And also in some cases we do see that the equipment becoming older is the element that we should consider. And for those cases we can think of increasing the amount we invest in that so that more equipment can be replaced.
And how can the railway companies take action in the future?
First and foremost, the thing that they should do is to do a thorough investigation into the cause and work out a proper set of countermeasures so that the same thing cannot happen again. And then I think it's important to share information among the rail industry within Japan because there are lots of things that people can learn from it. And those people who want information would be not only the train operating companies, but also the companies in charge of track maintenance or vehicle manufacturing companies, or many more, I think.
And since Shinkansen in Japan is known for its safety, I really hope that they could gain trust again.
I think so too.